Today we're going to add vectors, and we'll start out with the easiest way to add vectors, which is component or rectangular form. And we're going to use what's called a tip to tail method and do this geometrically first. Look at kind of the properties that we have and then develop an algebraic way of going about and doing this addition. So first thing I want to do in a tip to tail method is I want to graph my first vector. So I'll put 5, 3 on my plane, go 5 over, 3 up, put a little dot, and then since it's a vector I have to show its magnitude or length and its direction. Now this is called tip to tail once again, so what I'm going to do is I'm going to create a new origin at the tip of this first vector. And to that I'm going to connect the tail of the second vector. So the second vector is 2 over 1 down, and as I said, I'll connect the tail to this new origin and go to this point here. Now what I've created by doing this is actually the sum of the two vectors. If I connect those like so, I get what's called a resultant vector. Which is actually the sum of those two vectors. Now if I look at this resultant and look at its properties, it goes over 7 and up 2. And wouldn't you know that the sum of 5 and 2 is 7, and the sum of 3 and -1 is 2. So adding vectors in component form is super simple because it's just adding the x components and the y components. So when the problems get a little bit more difficult, I can just do my scalar multiples and straight add my x and y coordinates. So in this first problem I have 4b, which is just the same as multiplying the 6 by 4, which gives me 24, and the 2 by 4, which gives me 8, and 2a, which means -4 and 10. And then from there all I'm really doing to add the two vectors is adding the x and y components. So I have 20 and 18. Subtraction is very similar. If I have 8a, again I'm doing a scalar multiple, multiplying my a values by 8, so that's -16 and 40, and then I'm now going to multiply my b values by -3, and that gives me a -18 and a -6. And then I just combine those two by adding, giving me a -34 and a +34. That simple. Polar coordinates, much more difficult to do geometrically. Here's what we're going to do. We're going to take and add 7 and 30 degrees to 2 and 70 degrees geometrically. So to do this, we have to have our standard position set, and then we would have to take and construct a 30-degree angle with a 7-unit radii vector. So to do that, let's first go 30 degrees, just somewhere here-ish, and let's draw a vector of length 7. Here's 7 going down to 0. From that, since we're going to use this tip to tail method once again, I have to create my little axis at the tip of that vector and connect the tail of this other vector, 270, to that. So I put my measuring stick, if you will, right here. I construct a 70-degree angle. There's 70 degrees, and a vector of length 2. And that will give me enough to get a resultant vector. Let's do this. So I start from the beginning, rotate up, connect the dots, and that looks to be about 8.8 and 38 degrees. So it's a pretty involved task to add vectors in polar form. Now, wouldn't it be nice if we could just add their components as well? Well, clearly we can't, because we know 7 plus 2 is 9, not 8.8, and certainly 30 plus 70 is not 38. So there's got to be something else to it. So let's go to add these vectors algebraically. In order to do this, we've got to do three things. First of all, convert from rectangular or from polar form to rectangular form, add the rectangular components, which is what we did in our first example today, and then convert back to polar. Now, we have all these conversions. We did this when we were working with polar coordinates. To go from rectangular to polar, we know that x equals r cosine theta and y equals r sine theta. So let's go ahead and do that with both a and b. So if I have 7 cosine 30 and 7 sine 30, that gets me my a value conversion. Likewise, for b, that's 2 cosine 70 and 2 sine 70. For a, I end up with 6.06 and 3.5, whereas b gets me 0.68 and 1.9. And then what we want to do is we want to add these up. So if I take and stack them on top of each other, go ahead and add, I'll get 6.74 and 5.4. This is the sum in rectangular form. Then our next step is going to be to go ahead and convert back to polar. Now we remember our polar conversions state r is equal to the square root of x squared plus y squared, whereas theta is equal to inverse tangent of y over x. So we'll go ahead and do that. We'll take 6.74 squared plus 5.4 squared, square root all that, and then take the inverse tangent of 5.4 over 6.74 and calculate that value. And this is going to give me about 8.7 and 38.7 degrees. And that's my r and my theta from adding the two. Comparing that with what we did geometrically, let's take a look. We had about 8.8 and 38 degrees. And again, since these aren't great implements as far as measuring total length and so on and so forth, there's a little bit of fudge factor. That's a pretty close approximation. So let's just do one more for kicks. Alright, we want to take and find 2a plus b in this case, I'll multiply a scalar multiple of 2 by this a vector, thus giving me 6 and 65 degrees. B is just 8 and 170. We'll go ahead and convert these. So we'll take 6 cosine 65 and 6 sine 65. Add that to 8 cosine 170 and 8 sine 170. Then we'll add those together. This will give us our rectangular form, which is negative 5.34 and 6.83. And once again, this is our x and y value. We'll now have to convert this to r and theta by taking negative 5.34, squaring it, 6.83, squaring it, and square rooting that whole thing, and then finding the inverse tangent of 6.83 over negative 5.34. And once again, this gets me 8.67 as a radius and negative 51.9 degrees. But then I look at this and go, wait a minute, I get a problem, because negative 5 and 6.3 put me in the second quadrant, and 8 and negative 51 put me down in the fourth quadrant. So this is one of those cases that we talked about a couple of days ago, where we have to do a couple of reflections to get us over to this reference angle of 51.9 degrees. This blue line is our actual answer. So this has to be adjusted by taking and basically adding 180 degrees, or we could say subtracting 51.9 from 180. So what I really have is 8.67 and 180 minus 51.9 degrees for this value. So my final answer is 8.67 and 128.1 degrees. Always make sure you go back and check your final answer and make sure it kind of jives with what you found that point to be in rectangular form. That's all we've got today. Again, there's no Connect Ed, and just make sure you fill out your lesson summary and get back to me.